Welcome to question 1 of the 2016 VCAA Mathematical Methods Exam 1 for the Southern Hemisphere. In this video, we will be looking at the solutions and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for question 1, for part A, we have let y equal cos of x divided by x squared plus 2. And our question is to find the derivative dy dx. If we have a look at the function that's been given to us, we can identify that it's a function divided by another function, so we need to use the quotient rule. When using the quotient rule, we let the top line of the fraction be u, so u is going to equal cos of x, and we're going to have the bottom line, or the denominator, as equaling v, so we're going to have v is equal to x squared plus 2. So that means that du dx, the derivative of u, is going to be negative sine of x, and a reminder that that rule can be found in your formula sheet. And the derivative of v dx is going to equal 2x. So looking at your formula sheet, you would find that the derivative d dx of a function u divided by v is equal to v times du dx minus u times dv dx, all divided by v squared. So for this particular question, we're going to have that dy dx, the derivative that we're looking for, is equal to v, which is x squared plus 2, times du dx, which we found to be negative sine x, and then that is going to have subtract, and the function u is cos of x, and that is multiplied by dv dx, which is 2x, and then all of that is divided by v squared, so we're going to have in brackets x squared plus 2 all squared. So that is the answer to part A of question 1. From the examiner's report, we can see that 56% of students received 2 marks, while a third of students received 1 mark for this question. Around 11% of students received 0 marks. And the examiner noted that most students were confidently able to apply the quotient rule, which is what we used on the previous slide, and that formula is available on the formula sheet. However, many students did not obtain full marks due to errors in their working. For example, the denominator, which should have been x squared plus 2 all squared, was often incorrectly given as x to the power of 4 plus 4. Students should be reminded that if that was to be expanded, that should have been x to the power of 4 plus 4x squared plus 4, which is obviously not equal to what many students wrote. Another error that occurred was the placement and usage of brackets. So students are reminded that x squared plus 2 without brackets times negative sine x is not equivalent to the one containing the brackets. If we were to expand both of these expressions, for the first one we'd find that it would be x squared minus 2 sine of x, which would not equal the second expression when we expand that, which would be minus x squared times sine of x minus 2 sine of x. For part B of question 1, we have f of x equals x squared times e to the power of 5x, and we are asked to evaluate f dash, the derivative, when x equals 1. So if we inspect our rule of f of x, we can see that it's 2 functions multiplied together, so that means we need to use the product rule. And when we use the product rule, we let u equal the first function that's being multiplied, which is going to be x squared, and we're going to let v equal the second function, which is e to the power of 5x. We can then find du dx, the derivative of u, which is going to be 2x, and dv dx, which is the derivative of v, which is going to equal 5e to the power of 5x. So if you look up the product rule on your formula sheet, you'll find that d dx of u times v is equal to the function u times the derivative dv dx plus v times the derivative du dx. So for this question, we find that f dash of x is going to equal, and u is x squared and dv dx is 5 times e to the power of 5x. So we can write that multiplication as 5x squared e to the power of 5x and then we add on to that v, which is e to the power of x, times du dx, which is 2x, which we can write as 2x e to the power of 5x. We now need to evaluate this when x is 1, so f dashed of 1 is equal to, and it's going to be 5, and then wherever there's an x we replace with a 1, so it's going to be 5 times 1 squared times e to the power of 5 times 1 plus 2 times 1 times e to the power of 5 times 1. Simplifying that gives 5 times e to the power of 5 plus 2 times e to the power of 5. And as they are like terms, we can combine them, so this is going to equal 7 times e to the power of 5. So that is the answer for part B. So from the examiner's report, we can see that nearly 70% of students got both marks in this question, and 18% got 1 mark in this question. Most students were able to identify the product rule, which we did on the previous slide, but often they did not evaluate, or their answers were incomplete. And we can probably understand that to mean that they didn't progress from this line to this line well. Another error was an incorrect combination of the product and chain rules, which resulted in an answer of 10x times e to the power of 5x, which was incorrect.